Welcome to our session on artificial intelligence data sampling. In this session, we will explore how auditors approach the massive datasets used to build and operate artificial intelligence systems. We will cover the core differences between traditional auditing and artificial intelligence auditing. We will also walk through the specific methods you can use to select data for testing, including random, stratified, data splitting, and judgmental sampling. Understanding these sampling techniques is incredibly practical for your day-to-day professional life. When your organization wants to purchase or deploy a new artificial intelligence tool, you cannot possibly review every piece of data it learned from. Knowing how to extract a meaningful, mathematically sound sample allows you to confidently assess whether the tool is biased, secure, or ready for enterprise use without spending years looking at individual files. Let us start by looking at why auditing an artificial intelligence system feels so different from a traditional audit. In a standard financial audit, the data is usually contained and manageable. Artificial intelligence relies on an incredibly large volume of data. This data is highly diverse and is constantly pulled together from many different external and internal sources. Because these datasets are so enormous, it is simply impossible for an auditor to test the entire population of data. Imagine trying to inspect every single drop of water in an entire city reservoir. You would never finish the job. Instead, you take well-planned cups of water from different areas to test the quality. Similarly, we do not expect an information systems auditor to sit down with a calculator and manually redo the complex mathematical equations the artificial intelligence model performs. Instead, the auditor must carefully plan how to sample the data. You must decide the specific sampling method and the exact size of the data sample early on. This planning happens during the initial design and scoping phases of your audit. This brings us to the concept of data population sample testing. The size and the scale of the information used to train the system dictates how you will approach your sample. Sometimes you might actually be able to test the full population of data. If a company builds a very narrow artificial intelligence tool to analyze just a few hundred internal policy documents, the dataset is small enough that you can review everything. However, for most modern algorithms, the training information is just too vast. When the data is too large to test, you have to shift your focus. Instead of testing the data itself, you evaluate the processes and systems used to collect and organize that data. Think of it like a giant bakery producing millions of cookies. If you cannot taste every cookie, you audit the recipe, the ingredient suppliers, and the oven temperatures. In technical terms, you are measuring validity, confidence. This means you are checking if the type and the variety of the data are trustworthy. By understanding how the data is managed, you can spot integration risks and identify hidden vulnerabilities in the system. When you determine that you need to pull a sample, there are three main methods you can use. The first is random sampling. This is exactly what it sounds like. You select records blindly from the total dataset. For instance, if a bank uses an artificial intelligence system to predict loan defaults based on 10,000 past applications, you might just use a random number generator to pick 100 of those applications to review. The second method is stratified sampling. Stratified simply means arranging things into distinct groups or layers based on specific characteristics. Instead of picking totally at random, you first group the data. Going back to our banking example, you might group the data by the income bracket of the applicants. Then you ensure you randomly pick an equal number of applications from low, medium, and high income brackets. The third method involves data splitting considerations. When developers build artificial intelligence, they usually chop their data into three separate buckets. One bucket is used to train the model, one is used to validate it, and one is used to test it. If the developers split their data using a ratio of 60%, 20%, and 20% across those buckets, your audit sample must be selected using that exact same ratio. Now let us look at a specialized approach called judgmental sampling. Judgmental sampling is a type of non-probability sampling. Non-probability just means the selection is not random or based on mathematical chance. Instead, the sample is hand-picked based purely on the professional intuition and experience of the auditor. This method demands a high level of subject matter expertise. You use judgmental sampling to verify if the model outcomes are accurate, or to check if the training data genuinely represents the real-world environment where the tool will operate. You are essentially sifting through the noise to find the most critical data points. Imagine an artificial intelligence system designed to predict structural failures in bridges. To audit this effectively, you cannot just be an IT expert. You need a deep understanding of civil engineering, metallurgy, and stress testing. With that specialized knowledge, you would intentionally bypass standard, stable bridge data and deliberately sample data from bridges built in extreme weather conditions or with unique architectural designs. Your personal expertise tells you exactly where the risks hide, allowing you to select the most meaningful samples. Let us summarize what we have covered. Artificial intelligence auditing differs from traditional audits because the sheer volume of data makes testing everything impossible. Instead of recalculating math, we audit data collection processes and carefully plan our sample sizes. We explored random sampling for blind selection, stratified sampling for category-based selection, and matching the data splitting ratios of the developers. Finally, we learned that judgmental sampling relies entirely on your specialized subject matter expertise to zero in on high-risk data. All the important topics and concepts from this session are covered in the multiple choice questions on RooCloud.com. You should ideally solve the chapter-wise questions to reinforce your learning before moving on to the next session. Best of luck with your studies and keep up the great work, and I will see you in the next episode.